before I start this presentation, I want to thank everyone who joined this event. And I am SHANG-DE Jiang. I'm a cybersecurity researcher at Cycraft. So today my presentation is about the Dojo of Blue, how adversary emulation can enhance blue team performance. So let me quick introduce myself. So I am researcher at the Cycraft and speak of the HITB and this year Black Hat USA. And also I'm the UCCU Hacker co-founder. UCCU Hacker is a private cybersecurity group in Taiwan. And my company is our Cycraft. Cycraft is a AI company, so we use an AI solution to solve the security problem. So we have the investigation platform and the threat hunting sensor and the CTI platform. So these are three of our major products. And today, the reason I want to introduce this presentation is because when last year we joined the MITRE ATT and CK evaluation, and today the presentation is about adversary emulation, because we use adversary emulation to practice before we join the evaluation. So before we read into the agenda, and I want to mention the maturity level about how we do the self-assessment in privacy. So in the first stage, we will use a vulnerability scanner to do the vulnerability management to see what possible vulnerability in our endpoint. And we move on to the next level, to the penetration testing. And we do a penetration testing, but only for the external things or some major internal server. And we move forward to we build the internal rating or do the blind rating. We invite the external team to attack to our organization environment. And for now, most organizations are moving forward to the impersonal or continuously reporting, like binding the blue team and the red team together to make them working perfectly. So why we are doing the adversary emulation? Actually, the adversary emulation you can do in the penetration team, rating, or reporting. But the most important part is about checking the detection and the investigation capability. How can you detect this previous threat? Can our product detect a known threat happen in the other organization or in my organization history? And after you identify, you can detect this attack, then you can see do we need to add more detection about this attack, or we can move forward to other attack. And also you can use adversary emulation to validate your SOC team or your blue team to check them still awake. If after the adversary emulation finish, but the blue team didn't awake anything, you can adjust then the strategy, or do you missing some product so you cannot detect it. So this is the reason we want to do the adversary emulation. And today we will introduce our adversary emulator. So the adversary emulator is different with other adversary emulator. Our goal is first, most important thing is easy to build the environment. And we want to continuously to add the new framework. Because we are security vendor, there's every month, every quarter, there's a lot of new attack framework coming. So we want to do this. We want to design a easy and can maintain the API interface, we can add more attack framework to our testing case. And we also want to training our analysts to enhance their investigation skill. And also, it's the most important thing is make historical security event can be replayed. It's the most important thing where we have we have monitored a lot of customer and we notice a lot of HITB group. So we want to can replay the attack and the training our analysts. Now, okay, this is today my session agenda. So I will introduce our attack emulator architecture. So I will introduce how we design and what module we have. And the second one, I will introduce about Adversary Emulation, how we design the process and how our process work. And the third one, I will introduce what attack framework we integrate. And the final part, I will introduce how this whole process to impair and enhance the blue team performance and their operation. So this is our architecture quick overview. So we have a virtualization. So the virtualization can tell the rating and blue team to know what happened about this time emulation. And then the management console can tell the attack module and the infrastructure builder to tell the infrastructure builder first to build out the environment and tell the attack module to execute a specific command. And we also have the CLI console. The CLI console can directly interact with the attack module. So we can, if the rating want to add the new attack, so they can use the CLI module to directly execute the command. So I want to introduce the infrastructure builder first. So we use the Docker and the Falcon. For the Docker, we use the Docker for our server console. So our virtualization, syslog, and the management use the Docker. And why we need syslog? Because once we execute the attack command, we will send some IOC or the TTP information to a syslog server. And our management console receive the one task. So it will tell the infrastructure builder to build out the fitting infrastructure topology. We will auto create the networking and the endpoint information. And the infrastructure builder will use our Falcon API to execute. And the management will tell the Playbook builder to get ready, set out the rating environment like a C2 communication channel and a C2 server communication. And the final, the attack module will execute, and the Falcon API will execute the agent inside the virtual machine and execute the initial backdoor. And this is the image is on the screen is our API design. As you can see, we have a management console just like a preview state, and there's an environment, and there's a submodule called endpoint. The endpoints can tell us the status and some simple setting about the endpoint. And we also have attack and the playbook. They are separate, but they are working close together because attack just for we integrate attack module framework. So the playbook is about the story, about how the attack working, about on the fitting A, they execute some command first, and then later move on to a fitting B, something like this. So the playbook is about story. And the right hand side is our procedural code about how we work. So we can use the infrastructure builder to build out the Windows 10 or Windows Server and auto create the machine and add the network topology. and we can see what playbook we can choose, and use the playbook we choose, and automatic start the attack. And because if we want to start build out adversary emulation, you must have the environment first. But build out your own environment takes a lot of time to select the endpoint, backend, and build out the image, OS image, something like this. And so there's two great projects you can reference is a model lab and the attack range. So because this can save your time to build out the OS image, so you can reference this project. And this is our attack simulator last year. So this is our first version. So the first version in our adversary emulation, you can see there's a visualization about what happened in this APT operation, and the attack, later move on to a filter A, and later move to a filter B. Something like this, and the right hand side is what command has been executed when the attack do the adversary emulation. And in this year, we make a big change of our server virtualization console. So our virtualization console changed to this is still the same. Has a attacker to later move on to which endpoint and how they later move on. And the right hand side is a command they execute. But that's the most important thing is about the timeline. The timeline tells the blue team what happened about for example, that the command execute, that user command has been executed like 7 p.m. and what happened before this command and what happened after this command. So we can use time. The blue team can see this virtualization console to know what happened before the event happened or after. So after we introduce our adversary emulator architecture, so I want to introduce how we design the whole process and how we design the attack playbook. So in this screenshot, you can see we have the attack module and the playbook. So the attack module has supported multiple playbook. So what inside the playbook? The playbook is our storyline. So the storyline has some information about what the environment they need and what attack command they want to execute, and this will really reference to the attack module, and the attack module will execute a real command for the playbook. They say they want to execute the bypass UAC in the Metasploit, so the attack module will really execute the attack command. So the playbook is about the story, so we can support the multiple playbook, so we can attack the multiple playbook in the one time, so this can increase when the blue team start investigation. And how this is our playbook design concept is about. Because there's a lot of we call the adversary emulator or some TTP testing, but that's not enough for us, because we think the TTP testing just a basic part. We must test the TTP, but we also want our playbook can has a modularized attack produce, and we want the story, because we are not just detect that. We must let the blue team to understand what happened the attack. So the story is very important to us, and the story can enhance the blue team enhance the blue team investigation skill. So we are not just detect the technique. So we also want to enhance the investigation skill. So this currently we have the 3 playbook. So the first tool you might familiar with this, we based on the MITRE 18CK evaluation. So we create the APT3 and the APT29 playbook. And we also create another customized playbook we call Dogeza. And this is our Dogeza playbook scenario. So we have totally in a filter environment, we have 3 desktop. And this is 3 desktop, and right hand side is some build-out environment information. And we have a Linux machine and the Windows machine, because we want to see how the booting and how the booting investigation about the cross endpoint and the cross OS. Because there is a Linux and Windows machine, how the Linux machine later move into the Windows, and how the booting can detect and investigation this. So this this Dogeza playbook step. So this first part is our booting need to build out the environment and deploy the security software. And the rating will start attack the user web exploit to attack the filter A, and the filter A to use the SSH key for persistence, and install kernel root key to the filter A, and create a tunnel to the internal networking, and later move on to internal web server, and finally later move on to our last endpoint to get some information they want. And after the rating finish attack, we also call Adversary Emulator. We finish the attack. The booting will show how when the attack happened, what they detect, and what they investigate when after this attack. I want to break down our playbook Dogeza, the attack produced. So we will in the first initial access, we will use a web exploit, elFinder. So elFinder is a famous famous file manager for web. So it has many third-party integrate like Django, Drupal, Laravel. So it's very wide in public use. And we use the CV is a command injection vulnerability for the elFinder. So this remote command execute, and it's very easy to launch an attack using a Metasploit. So we choose them to the Dogeza playbook initial access point. So our rating will doing the web exploit and address his privilege through a CH rootkit. It's also known as non-exploit. So the threat actor can use this exploit to invoke to get the root access, root privilege. So this it will generate and put our reverse shell in a temper update, and compared to the kernel rootkit, it's a kind of privilege calculation and more stable and more easy. And after we do the privilege calculation, the rating will doing the SSH persistent key. So it's threater will drop their own SSH key, so they can easy to move back to this filter machine anytime and use a SSH. Even they patch the web exploit, they still has a SSH permission. And after they do the persistence, then the rating will install a rootkit. So it's hiding their backdoor and prevent the detection. So in this scenario, we use a retail rootkey. It's a kernel mode rootkey and the most famous. And if you find in GitHub, you can see almost the start of the GitHub project. And after the thread install rootkey, they want to do the network tunnel and use the network tunnel to reach the internal service. So in this playbook and in this environment, we set up internal web service, and the thread editor can use the first endpoint to do a network tunnel and get access to an internal service. So while many IT put a lot of defense on the external networking, but the inside network maybe is still vulnerable. So in this use case, we use Escalate for tunneling. But it's not really malware, so possibly if your Linux server install antivirus, but maybe you still will not detect this one. And then we move forward. We initial access the internal web server, and we also use a web exploit and deploy the malware to the Windows server. And we get into internal web server, and we will do a privilege escalation from IIS system service privilege to the system. So in this case, we use a juicy potato, which we call MAT. The CV number is we use a juicy potato, and we use because it is by the Windows system architecture design, so it's expect the Windows Server 2019. Other Windows Server platforms still has this vulnerability. Can let the other user account to do the privilege escalation. And meanwhile, after we get the system permission, so then we can use a Mimikatz to do the credential dumping and get some credential, and then we can do a later movement to the return C. So in this final step, we later move on to a return C. We can use a credential from the previously. We can use a BitAdmin, PSQ, WNI to do. We have a lot of options can do later movement, and we will use some tool to do to get some information we want to do a recon, and we will collect some information from the return A, B, C, and use a Windows Maccap to compression the data we want and send out to the attack machine. This whole step are in our Playbook Dogeza. So the whole environment is from the Linux machine to the Windows machine, and do the data exfiltration, and also use a network tunneling. So this is a classical APT case study. So we symbolize the real case and do this playbook. Okay, let's move forward to the attack toolkit integrate. So in this part, I will introduce what post-penetration framework we integrate and why we chose them, the pros and cons, and we repurpose the APT malware and why we choose them, and what the APT group malware we choose. And the first framework we integrate is Metasploit. So we integrate Metasploit. I think most people has familiar with this. The pros is Metasploit has a great community resource. Always has a great latest exploit and vulnerability scan. And the Metasploit has a well-designed session management, so we can easy to integrate. And what that comes is when we try to developing the wrapper of Metasploit, we notice we need to interact with the Metasploit RPC server. it's quite complicated when we trying to interact with this. On the right hand side is our sample code about we modularize the silent cleanup bypass UAC for the Metasploit. So you can see we parameter the session and the local port. Because this attack is quite easy, so we don't have too much thing we need to modularize. And we will, after we execute the attack, we will check do we receive the new agent, new session from this attack. So we modularize every Metasploit attack we want to use. So this is one of the sample. And the second is the second framework we integrate is the Empire. So why we integrate with the Empire? Because we want to demonstration the fileless attack. So previous Metasploit has a traditional penetration framework, but Metasploit has a fileless, but not pure fileless. So we use a Empire. And the Empire has a very simple agent management design, so we can do our own agent management. But there's a concept about because starting last year, I remember the Empire stopped maintain and the developing. But there's a lot of success. If you want to do integrate the fileless post penetration framework, you can choose other project. And we repurpose the APT malware. So why we want to repurpose the APT malware is because we are security defender. We want to close the real world case. And so we choose the most APT attack, APT group in the Taiwan. So in this repurpose malware, we choose the APT group water bear. And because we research and we found a lot of APT malware in our customer, and we reverse a lot. So we found that APT malware usually has a well designed to have the security product. So we want to make sure every time we doing this, we can find the APT malware. So the APT malware we repurpose is we call the DBGPRINT. So the DBGPRINT is coming from the APT group Waterbear. Maybe you familiar with is the name aka is Plead or the bad tech. The DBGPRINT is starting from since the 2009, and there's a lot of version about the DBGPRINT. Like the talking security product by inject the shellcode to evidence the security product detection. And also the runtime decrypt and decrypt the encryptor function. So only when DBGPRINT will decrypt the function, encrypt function when they are used. So only one function will be decrypted when you do the memory process. And they use a lot about anti-memory forensic. So the DBGPRINT is the most major function is a remote download DLL and load and execute in the memory. So this is a DBGPRINT staging flow. So the first thing, DBGPRINT will check the debug environment and then relocate the function table. And locate the function table and initialize API from the hashed function table and get the DLL. So there's two options when they are using. First option is remote download the DLL from the C2 server. And the second one is the load from the local file. It depends the different operator, they will use a different option. And the final part is get the DLL and decrypt the DL file and inject and execute in the memory. So the last part is we replace our integrate toolkit like previous Metasploit and the Empire. We replace this one and drop our payload here. So after we introduce about what attack framework we integrate, so I will want to introduce about the blueprint part, because previously we say it's about how the Adversary Emulator working and how we design. So for now, I want to introduce how the blueprint evolution about the detection and the investigation. So the first thing I want to say is about the detect target. So the blueprint must choose one technique they want to detect it or investigation it. So for example, we take a demo case about using a PowerShell to do the OS credential dumping. So we take an example about ATT and CK inflation, APT 29 step 6. They use a PowerShell dump OS credential. So this is just a demo use PowerShell. We use a CMD and open a CMD and execute a command to download a remote script and run the PowerShell version Mimikatz. And this Mimikatz will dump OS credential and by the PowerShell. So how we detect this? We can have many levels for detect this. So I will introduce one by one and why we want to move forward to the next level. So the first thing we can detect this previous attack is about using detect the command line. So we can detect the command line to the PowerShell. So we notice there's a new process called PowerShell, and the PowerShell command line has the info Mimikatz like this command. So we can do the simple string match to detect this attack. But as you can see, so if you change your command line name or some command, maybe you change the info Mimikatz to the AAA, maybe you cannot detect this. So also the APT group or the adversary, they will notice. So they will move forward to next level if they bypass this. So how we detect this? So the next level is detect the process load library. So because the normal PowerShell process would not load some Windows DLL because they don't need it, so they would not load this library. But if you execute Mimikatz, so you will load some suspicious library, so you might can discover there's a possible credential dumping on this process or on this PowerShell. And the third one is check the PowerShell event log. Just like our previous demo case, the attack method we want to detect, it will load a remote PowerShell script. So it will create the script block event log. But it's starting latest PowerShell version, so it still has some chance to bypass this. Like some attack will use old version like a PowerShell v2 to bypass this event log, because PowerShell v2 don't have this event log. So it also can be bypassed by the adversary. And the fourth method we can detect is check the API, the code API. So just like most of the EDR product, the EDR product will monitor the system API call. So the PowerShell will call the .NET library, and if you can hook the all API call, then you can know every process include PowerShell, what they are doing in this process. So you can know for example, the PowerShell Mimikatz. The Mimikatz will load, when they dump credential, Mimikatz will load the OSL SAS executable process memory. So it will load the memory to the LSAS. So it's a suspicious behavior. So you can create a detection based on this. So you can find a maximum PowerShell has access to other LSAS process memory. But doing this detection are very costly because you want to monitor every API and do a customized detection. And the next level is AMSI, Microsoft Anti-Malware Scanning Interface. So the anti-malware scanning has many functions. So one of the functions is scan every script like a PowerShell VB script. The PowerShell command will send to AMSI scanner. The AMSI scanner will elFinder can use the AMSI to record it or scan the string about what the command has been executed. So we can do the recording about the Mimikatz script. So if you notice the whole detection method, the evolution is actually is a data source. So based on the previous, the first thing we can detect is by the process command line parameter, and the second one is what the process has loaded the DLL, and the third one is do we need collect more Windows eventlog, and four is API monitoring, and the final thing is AMSI. So after we notice that at the first the rating can has multiple methods to bypass our detection. So we will notice what we missing in our secure environment or in our product. So the blue team can notice this question, and they can enhance their security solution. But the thing about the adversary emulation enhance the blue team performance not just about the detection, because the blue team not just detect the threat, they also need to investigate the threat and find a threat, do a threat hunting. So for us, because we not just only detect the threat, we also want the blue team can handle the threat. So for us, our will do is investigation. So when doing adversary emulation, what's the benefit for the whole security team, for the red team and the blue team? So I want to do the conclusion about this part. So the key benefit for the red team is about so the red team can know how the blue team do the defense. Then they can know how they do the defense. They know how they can bypass it. So they skill can keeping the level up, and also they can provide more value for the organization. Maybe in some organization their rating is still fighting with their blue team. They didn't work together. So if we do an adversary emulation, the rating and blue team will working closer. So they can have opportunity to make a good communication with the blue team. And for the blue team, the key benefit is about continuously to developing and validate their detection. This is the most important part for if you run the own threat hunting team or your own security team. This is a very important part. And you also can handle the known threat. You must handle the known threat in your organization history or some other organization. There's an old trick, but if you the old trick, you cannot handle it, or you cannot detect it, or you cannot investigate it. How you can deal with an unknown threat? And you can also identify, just like we previously say, the data source. So you can identify what data source you are missing. And you also empower your if your blue team has a new member, you can use our Adversary Emulator, something that designed like this, the Playbook, to training them how do they do the real investigation, and they skill up their investigation skill. So above are my presentation, and thank you for your time and your listening. If you have any question about Adversary Emulation or my presentation, I will be on the Discord channel and answer your question. Thank you.